Hello everyone, we are Group 9 and today we are going to explain to you on the Heuristics 43 until 48. Enjoy! Heuristics 43 states that if we want to increase the pressure of a stream, it is more preferable to pump a liquid rather than to compress a gas, unless refrigeration is needed. So for example, if we have a vapor stream and we want to increase the pressure of this vapor, there are two ways to do it. Diagram A shows the first way, where the low pressure vapor is first condensed to become a low pressure liquid. And after pumping this liquid, the pressure of the liquid will be increased. And this liquid will then be evaporated to become vapor. Diagram B shows the second way, where the low pressure vapor is directly compressed to a higher pressure vapor using a compressor. This compressor uses 1000 horsepower while the pump will only use 10 horsepower, which is a huge difference. Therefore, pumping a liquid is usually more preferred than compressing a gas, as stated in Heuristics 43. So now we want to know why. Because it is far less expensive to pump a liquid rather than to compress a vapor. This is because the power required to increase pressure of a flowing stream is denoted by this formula where W is power and V is volumetric flow rate. So power and volumetric flow rate is directly proportional. Therefore, as volumetric flow rate is high, power required will also be high. And volumetric flow rate is normally far less for liquid streams. So therefore, pumping a liquid stream will usually require much less power when compared to compressing a gas. In conclusion, pumping a liquid will require less power, so it is less expensive. And vice versa, compressing a gas requires more power, so it is more expensive.
Here is one example. Ethyl benzene is taken from storage as a liquid at 35 degrees Celsius and a pressure of 1 atm. It is to be fed to a reactor as a vapor at 400 degrees Celsius and a pressure of 5 atm. There are two alternatives to position the temperature and pressure increase operations. For first alternative, the liquid at 35 degrees Celsius and 1 atm is first pumped using a 12.5 brake horsepower pump, which increases the pressure of the liquid to 5 atm. Then, the high pressure liquid is heated to change it to vapor at 400 degrees Celsius and 5 atm. For second alternative, the liquid at 35 degrees Celsius and 1 atm is first heated to become vapor, and after that the vapor is compressed by 1897 brake horsepower compressor to increase the pressure to the vapor to 5 atm and 400 degrees Celsius. The difference between these two alternatives is first alternative increases the pressure first, then changes the phase. Meanwhile, the second alternative change the phase first, then increase the pressure. You can see that the compressor require much higher power to increase the pressure of the steam when compared to using a pump. Therefore, alternative 1, which is pumping a liquid to a higher pressure, is more favorable than alternative 2 when vapor is compressed.
Heuristic 44 and 45 are the heuristics in vacuum condition. For heuristic 44, we need to estimate the in-leakage of air. This is because the vacuum equipment can cause in-leakage of ambient pressure air, which means the air from the outside is leaking to the inside. So, to design a vacuum system, we need to estimate the in-leakage of air by using this formula. Basically, the air in-leakage are in flow rate unit, which is pound per hour, and volume of the vacuum equipment is in feet cubic. K value are depending on the pressure value based on the table here. Use 0.2 if the pressure is above 90 torr, 0.15 for pressure in between 89 to 21 torr, 0.1 for pressure 20 to 3.1 torr, and 0.051 for pressure 3 to 1 torr. Heuristic 45 are explaining about using condenser before the gas entering vacuum system to reduce the amount of gas if the temperature above 100 Fahrenheit. Generally, the vacuum function is to remove the ambient pressure air and vapor from this process steam. So, by using condenser, it helps to cool the air and the gas leaving the condenser will be at a dew point temperature of 100 Fahrenheit at the vacuum pressure. In other words, the gas will change its phase to liquid and it will condense to the surface of the equipment.
Now I will be explain about heuristic 46 and 47. These two heuristics describe about the two equipment that used to create vacuum condition to perform separation process. The first one is liquid ring vacuum pump. The pump contains liquid water and combined with the impeller to form a liquid ring. The pump can have a gas flow rate at the inlet maximum up to 10,000 feet cube per minute, while it can produce a minimum of 35 torr of vacuum condition pressure in a single stage and 10 torr for multi-stage pump. For your information, vacuum condition can be created at a pressure below of 760 torr, which equivalent to 1 bar. Next will be steam jet ejector system. This system can have up to 1 million feet cube per minute of gas flow rate at the inlet and can create minimum of 2 torr of vacuum condition. In order for 3-stage ejector to achieve 2 torr of minimum pressure, 100 pounds of 106 steam per pound of gas are required. Both equipment operate with a concept of by attaching the equipment at the overhead of the separation column. The equipment can drag out inert and other vapor to create vacuum condition.
Next, heuristic 48 state about solid particle processing in conveying granular solid. Usually, conveying consideration are the material stickiness and the abrasiveness with solid particle size and density. First, if solid particle with smaller size, low particle density with non-sticky behavior such as cereals, recommended using pneumatic conveying system. Figures showing method in unloading dry bulk material with pipeline. Blower provide conveying air to be pressurized. Once valve discharge is open, velocity of airstream increases. Particle will be picked up and carried in the airstream. This term is called as particle pickup velocity. Next slide. If material with sticky or abrasive behavior with any size and density such as cement clinker, using screw conveyor with rotating helical screw blade is recommended. Same goes with bucket elevator where typically use larger masses of bulk materials to different height. Overall distance is up to 150 feet. Meanwhile, for any kinds of size and shape of solid particle with non-sticky behavior, recommended to use belt conveyor. If necessary, use inclination up to 30 degree, transport, produce upward to multi-level setting to one platform and another.